Okay, and share. Right, here we are. So, yeah, very similar. So obviously we've got our core model here. So
you're showing us a spreadsheet.
oh, hold on, sorry. Zoom's being a real pain today. I'm not sure why. Let me stop sharing and do it again. Can you see it now?
Perfect.
Fantastic, thank you. So yeah, so very similar to what most of you guys had. So initially, we've got the proportion of eggs fertilized. So you could do that in two different ways. You could just model fertilized eggs, which is what I've done here, but you could model eggs and then a proportion of those are fertilized. You can do it either way. So here I've just got the proportion of eggs that are fertilized, which defaults to 1, but with a slider so that you can change that. So by default, all of the eggs are fertilized. And then this laying rate just becomes the same as before, except we're also multiplying by the proportion of eggs fertilized. So if they're all fertilized, then we're just multiplying by 1. If only half of them fertilized, we're halving them, etc. So I noticed a couple of different ways of doing this. The way I did it, because it's simpler to think through, is to separate out the 2 different types of death. You don't have to have stocks, except if you want to keep track of the number of dead chickens, which I don't know, maybe you do. I've decided I will. So I've got chickens dying from natural causes and chickens dying from predation. So those dying from natural causes is basically the number of chickens divided by 364, which is 7 years, so in weeks. And then for the foxes bit up here, we've got, we start off with 100 foxes and 0 kits. The kits are being born, so they're coming from nothingness into the kit stock at a rate which is defined by 5 over 52 times the number of foxes. So each fox will give birth to 5 kits a year, which means that each week 5/52ths of a kit is being born per fox. So it'd be 5 over 52 times the number of foxes. And then kits reaching adulthood, that flow rate would be, so it's 12 weeks. So each week in system dynamics world, 1/12 of a kit becomes an adult, and the other 11/12 of it presumably just are waiting around. And then of course foxes also die, and they die after 4 years, which means that 1/208th of each fox dies per week. So yeah, we have foxes over 208, so 208 weeks. And then of course you've got the interaction between the two. So the way I've set this up is by having chicken mortality from predation, and we've got a fox predation rate. So here I've specified the rate as being, the default rate as being 0.2. So in other words, how many chickens does a single fox kill per week? Well, they kill 5. They kill one chicken every 5 weeks. So in system dynamics world, that means that each week they kill 1/5 of a chicken, so 0.2. And of course, it'll also depend on how many foxes you've got. So it simply becomes the fox predation rate times the number of foxes will give that chicken mortality through predation. So if you run that with the default, and we look at chicken, oh, actually, I'll have to do it by the table because of my resolution. Then what you'd find is that you get this this chicken explosion, as you saw. I'll just bring up the answers. So a couple of you, I think, got as far as this. So if you explore around and change the different factors, so assuming that everything else stays the same, you should find that you need at least around 8% of your eggs to be fertilized to ensure your chicken population doesn't die out. And for the other question, assuming that 80% of eggs are fertilized, how murderous do foxes need to be? It turns out they need to be around 5 times more efficient killing machines. They need to kill basically about a chicken per fox per week. So about 5 times more than they're doing now. So I mean, it's a bit of a weird model, but hopefully it's given you an idea of how you build these kind of system dynamics models, and also the weird quirks that you need to think about if you're thinking in terms of a system dynamics approach. It is very different, and you can see why you tend to use these things more for understanding the general dynamics of a system rather than anything around, sort of resourcing or queues, which obviously just won't work properly in an ST model. So, oops. Okay. So I got you in that exercise to build on the model and then to use that model to try and find some optimum values. Now there is actually something built into InsightMaker, which is quite snazzy, which allows you to automatically try and optimize the model according to a certain outcome. So if I go into the model here, and then at the top right, oh, it's covered over on mine. Here we go. So if you click on the tools at the top right, one of the options is optimization and goal seek. And if you click that, you can basically tell the model to run lots and lots of times in order to get to a certain condition. So you can specify what you're trying to minimize or maximize. So let's say I want to minimize the number of chickens. So I'm a fox. I've built my system dynamics model. How do I get rid of these pesky chickens? So my primitive would be chickens. My goal is to minimize, and I want to select my goal type being the final value. I want to basically minimize the ultimate number of chickens. You can also select integral, which will obviously try and minimize and get down to a reduced rate of chickens, but usually you want final value for the sort of stuff you'll be doing. And then you can tell it what primitives you want it to adjust. So what do you want it to play around with? So in this case, I want it to change the predation rate. How many chickens do I need to kill as a fox in order to do this? And then once you've got that set up, you can just click run optimization, and it'll very quickly go through all the combinations, and it'll tell you the optimum. So here, the optimum here says the fox predation rate, the optimum is 1, which is what we found. They need to be 5 times more efficient at killing. And they explored the range between 0.9 and infinity as well. So it's quite, it gives you lots of information here about the solutions space that it explored. You can look at the different results, but it's quite a handy way to very quickly, I mean, that took 0.15 of a second to do that. So you can very quickly, particularly in more complex models, use that to try and get to a certain state. Another nice feature in InsightMaker is that it has automatic loop identification. So you remember back in the first session we talked about system dynamics models and how essentially they're all about the loops. So you've got reinforcing loops and balancing loops, and actually where you have loops, that tends to be where you've got interesting effects happening. You can use InsightMaker to automatically identify loops. So even if you're just doing a qualitative model, so where you're just doing a causal loop diagram essentially without any numbers in it, then you can put this together in InsightMaker and just get it to automatically pull out the loops that you've identified. So if we click on the tools up here again, there's an option here that says identify loops, and it will tell you how many loops have been identified here. So in this case, it's identified 2 loops. The first one being from the chicken stock into the laying of fertilized eggs, into fertilized eggs, into eggs hatching, into back into chickens. So that's a loop. So you've got chickens laying eggs that are then becoming chickens. And then you've got the second loop, which is kits, who are then reaching adulthood, who are turning into foxes, who are then giving birth to more kits. So it can automatically pull those things out, which is really handy, particularly if you're doing an exploratory piece. Initially, you probably want to be doing like a causal loop diagram to look at your system. And so you can just put together very quickly and easily, without any numbers, just stocks and flows, and it will automatically identify what your loops are, and you can then focus in on those particular areas. That's quite a nice feature. There's also a nice feature called storytelling. So you can very easily share your models on InsightMaker. So let me show you by making this public. So by default, I think it's private. But if you click on Edit Info on your Insight, you'll see it gives you the option to rename it. You can give it various keyword tags, and you can put in a description. And you can see there it says Insight Access. If you change that to public, which I'll now do to make the solution available for you, and click Save, that is now available to anyone who's wants to search on this or has got the link to be able to clone that insight. But what you may want to do, if you want people to be looking at this, is to do some fancy stuff around storytelling. So rather than just show them the model, you can tell them a story. And so if you click on Tools and, oh, it's hidden. Can't see it because of Zoom, sorry. Oh, it's here, sorry, Share. Storytelling, click that. And then it pops up with something called the Story Designer, which is, why is that not looking here? Okay, for some reason that's not working properly. Let me show you. I've got a pre-prepared insight. Basically what it allows you to do is to gradually show various bits of your model. And those, you can put little narrative comments alongside it. You can say, well, let me show you. So if I go into this, so this is the same version of the model, except it's got storytelling. So if I click step forward down here, it comes up with the chicken stock first, and I've put in a little comment saying first there were chickens, and that's the end of my story. I probably should have done a bit more. It's not a very interesting story. First there were chickens. That's very interesting, but it allows you to basically gradually expose bits of your model, so you can talk somebody who's looking at your model through it by showing bits, only certain aspects of the model at any one time, and you can add little narrative comments down here. It's quite a nice feature. It's a shame I can't get it working on the share thing. I'm not quite sure why, but have a look at that in your own time, because it's something worth looking at if you're going to be sharing your models. It's very self-explanatory. You basically just go in and say, I want this bit to be shown, I want these bits to be hidden, and this is the text I want to put. It can be quite effective. So, back here. The other key thing that is really useful in InsightMaker is the ability to be able to, as I said, to be able to share models. But that also, as from the other perspective, means it's really easy to be able to explore what other people have done. And so I showed you a minute ago how you could put tags on your insights, so that those are essentially keywords to allow people to search for models looking at certain things. So if I was sharing that model in earnest, I might put, chickens or eggs or something. So people looking for chicken and egg models may well then come across my insight. But you can do this the other way around by exploring insights yourself. So if I go to the main InsightMaker page, I can click Explore Insights here at the top. And this will allow me then to search on various, any keywords that I want. And it pops up with some popular tags that are being searched for at the moment. So there's lots of stuff around economics, environment, healthcare, unsurprisingly. Population growth. COVID obviously is in there as well, coronavirus. So these are the sorts of things that people are searching on. And obviously it's a kind of word cloud type thing where the larger the words, the more popular the search at the moment. but you don't have to use those. You can search on anything you like. So what I'd like you to do for the next exercise is to go back into your groups, and I want you to use that Explore Insights facility to have a look for system dynamics models that other people have built to address anything related to COVID. So any aspect of COVID whatsoever. It might be to do with resourcing in COVID. It might be to do with the spread of the pandemic. It might be policing issues around lockdown, anything at all. So I want you to have, as a group, have a good look at some of the stuff that's out there. And then once you've found a few, I want you to together pick a model that you've come across and explore that particular model a bit further. I want you to have a good look into how it works, what it's trying to do, get an understanding of what it's doing, and any results that are generated by that model. And then I'm going to give you about half an hour or so, about 35 minutes to do this. I'm going to ask you to come back, and then I'm going to ask each group to give a short, no more than sort of 5-minute talk, telling us all about the model that you found and that you want to explore. And in that talk, I want you to talk about the problem that the model seems to be trying to solve. I want you to give a brief description of how the model works, any sort of key results or insights that seem to be generated by the model, anything notable about the way in which the model's been built. So has it used storytelling to aid visualization? Have they used other visual aspects to do this? Have they used particular structures in the model that look quite interesting? And then to give a short critical appraisal of the model. What do you think of the model? Do you think it's a good model? What do you think works well? What would you have done differently? And it's, as I said earlier, it's really important to actually be able to critically appraise models. As I also said earlier, there's a lot of bad models out there. So you may want to choose a model and come across a model that looks really interesting and seems a really good, strong model. That's great. Equally, you might hone in on something that you don't think is quite so good, and it's entirely up to you. But find something interesting. So have a good look around in your groups. Have a look for various COVID models. You can either use some of the tags down here that are suggested, or just type in your own tags and see what you can find. And then we'll come back in about 30-35 minutes, and I'll get each group to just give a very short presentation on the model that you've looked at. Okay, everyone clear on that? Fantastic. In which case, I will pause the recording and I'll put you into your breakout rooms and I'll float around and listen in.
I can't quite see the top of the page. SEIL infectious disease model, I think. Yes, for COVID-19. And
are you able to share your screen? Sorry, Julia.
Yes. Do I share my screen? Right. Okay, hang on. Share that one. Okay. Can you see that?
Yep. See that?
Okay. So this is looks an impressive, thorough model. So having had that brilliant model the other week, from Devon CCG, we didn't want to find anything that wasn't really as good. And so we thought this stood up to the other one quite well. Mm-hmm. A lot of thought's been gone into it. And interestingly enough, it was produced 9 months ago at the very beginning, but reading through it and everything he sort of says, it's just as applicable now as it was then. So we're all doing exactly what he said to do then. So here you can see that he's got the vaccinations down one side and looking at that, which obviously at that point 9 months ago was a long, long way away, but we're much nearer it. And then he's got the total population in the middle, and he's got if you're susceptible, and then how they're exposed and probability of them being exposed, and then infectious with the incubation period put in, and then recovered at the end. And he's got some people not susceptible up the top there, which you can see, which is recovered and immune. He's got in the top corner. And so this is obviously, he did this when it was just in Wuhan. So he's looking at it from that point of view rather than the point of view of us. But it's as applicable to us as it was then. And he's got some improvements down the bottom that he suggests would make it better. So he's got that the people that are symptomatic would have lower contacts because they'd be aware that they were. So he feels it probably should be split by those people that are asymptomatic and those that are symptomatic. But obviously he hasn't done that, but suggests that will be an improvement to the model there. We wondered whether also an improvement to it was that this obviously was done before it was, it came here, but now it's here and we have the lockdowns, that probably we could factor the lockdowns into this, and the tier system as well, and then break down the rates and the susceptibility by those different tiers, and that would be a useful addition to this model. Is that okay?
Yeah, that sounds great. It looks like a really good model.
It does, doesn't it?
Yeah, no, absolutely. So that's really good, and I like the way he's included lots of information. And it's really nice. I mean, it's one of the advantages of open source,
Yes.
sourcing your models, that you acknowledge where it can be further
Yes.
developed, and hope that people can sort of take that forward.
Yes.
Brilliant. Thank you very much. That was great.
Okay, that's all right.
Okay, so let's go to group 2. So Heather, Matt, Mona, Richard, and Claire.
Shall I do it? I'll just share my screen.
Yeah, sure.
It's just, I think it's doing something. I don't know. So, can you see? We went again with another, what we think is a good model. So this one is an SIRD model. We did find another one which referred to the devil or Satan, and we thought, shall we go with that one? And then we thought somebody else would pick it and talk about it.
Right, okay.
So we decided not to. So what we like about this model is it's quite well laid out. It's got a good balance on the model itself. There's good use of colour to separate the different aspects of it. One of the things is this is broken up into bits that we recognise from other bits of work that we've done. So the asymptomatic, pre-symptomatic groups of people. The person who developed the model has done this a nice lot of explanations about the model. So there's a lot of text in there, but it's hidden, so you don't see it straight away. You can click on it and you can learn more about it. So we did talk about some of the things. So the important part of this model is it's simulating the effect of a quarantine and a lockdown policy on the COVID rate. So if I just click on simulate, I can't remember what it's doing at the moment. So we did take a little bit of time to figure out what these charts meant, because to us, we were looking at these graphs and the height of the graphs were the same. But in actual fact, the red graph that you can see there would have been the same in the blue boxed area if the policy hadn't been applied. So in some ways, it's shifting the deaths along, because in the blue box area is when the lockdown and the quarantine policies are in effect. So it's showing the red line down here is kind of like very, very small.
Oh, I see. Yep, yep.
Yeah, but we did find it a bit confusing because we saw the red line go up to the same height and we're thinking, what's going on there? So we didn't quite understand that part of it for a good while. I think, Claire, was it you who's thought of a criticism of this model?
I think we were just saying that the deaths wouldn't potentially go without the policy. It just implied that the deaths would go up and then come back down to exactly the same kind of curve, which didn't seem quite right. Also the policy, it just applied a kind of standard policy but without different effects. So kind of the lockdowns, we've had kind of different variations on there.
Yeah.
I'll just chip in a second as well.
Yeah.
The other thing, just this demonstrates, it shows reinforcing and balancing loops, which is a good thing to show. It also shows the use of ghosting, using variables and creating copies of them to keep the diagram less busy, which we weren't specifically trained on. So it's quite a good use of the tool in actually developing and presenting a model.
Yeah, it looks like there's some really nice features actually they put into that. It looks like a really well sort of thought out model actually.
We like the curved lines.
Yes.
It's got a few sliders as well. If you scroll down, we'll click on the main area there.
Oh, should I just there?
Yeah. So you can affect the obviously start and duration of the policy and the number of people expected to quarantine when the policy is introduced and the expected contacts per day. So you can play around with it a fair bit. And I like to see the fact he's basically stated in this is not to be used as a predictor, it's just for guidance, which is one of the mantras of model building anyway, isn't it?
Yes.
Dan?
Yes, absolutely. That seems really well thought out. There's lots of explanatory text, but it hasn't caused it to be overwhelming. Like I say, he's thought about how that information is visualized, which is really good. Yeah, it seems to be very clearly a model designed for people to use and explore, and lots of thought into how people will use it. That seems like a good, strong model. That looks really good. Great, thank you very much. Brilliant. Right, so on to room 3. So that's Adam, Bev, Josh and Matt.
It's me.
Okay.
Can you see something you might recognize, Dan?
Yep, that looks good.
Does it?
Well, I can see a screen anyway. So.
Yeah. Well, first of all, we managed to find Dave Spencer's model, and one of our team hadn't been here on that day, so didn't realise that was that. So we then looked for some other things. When we're looking for something
so I've just recognised it. Sorry.
Yeah. So we clicked on this one, which is by somebody called Dan Chalk, I think it was. And then we realised that it doesn't have any variables in it, so we thought we'll try something else. So we did do a lot of rummaging before we settled on something, and then we were actually really interested in this one, which again is by somebody called Dan Chalk. But it was just fascinating because there'd been so much problem around the PPE, rather than looking at another model like the others have been looking at, which was sort of similar to Dave Spencer's. But the more we looked at this, the more we felt that using this thing isn't very easy unless you have the story. And I really think you need to build up the story, because when you look at a page, you don't quite know where to start. And, you know, total PPE in hospital, that's fine. And we've got some variables we could play with, but they didn't seem to change things how we thought they might do. And we were a bit puzzled, Dan, with, I don't know how to make this, there we go. Why you'd chosen years for time?
Well, I could answer all those questions. It's not a working model. It's the easy answer to that.
Yeah, well, we sort of guessed that, but it was just one of those things that we thought, oh yeah, so it was good that because we saw some that didn't have any labels at all, and we found that was really difficult to work out what they were showing us, so we gave up on those. But it's still, even though it's good and clear, and because I don't like things that go round in a circle very much like some of those others appeared to do. I like something that flows through and out the other end. But we will, the more we looked at it, the more we realised that you still need to have a really good narrative to go with it, and how you would put that on, that you did with that story you were showing us before.
Yeah.
Because we still couldn't get quite to what it was trying to tell us exactly, what it was trying to show.
Yes, I mean that actually nicely demonstrates that. Well, so I mean, the first thing to say is that this isn't a public. Well, it is a public model, but so this came about. This was basically a doodle that came about a week after lockdown, following a query that came in around PPE and doing some PPE modelling. So we use this as a sort of doodle board, essentially, just to try and think through some of the issues. But that was we actually had another team in the university who are part of Sage who were doing this stuff anyway, so that was abruptly dropped. But it's actually a good demonstration. You're quite right. Of if we compare it to the previous model, that was very clearly a model that's designed to be used by people, and a lot of thought had gone into the usability and telling people how it works and the visual clarity of that. And actually, that's a really nice demonstration of, if you were, I mean, clearly I'd never intended for this to be used, but if you were building a model like this, you would need to think about, and you wanted to share it so other people would use it, you'd absolutely need to consider those kinds of things, because otherwise you'll end up with something that kind of makes sense to you and maybe the people you're working with, but would be very difficult to follow for others. So I think they actually did a discrete event model on this, which is probably the conclusion I'd have come to as well. But yeah, that's a really good point actually, and you'll notice just from what's actually a relatively simple initial diagram that things get very messy very quickly.
Yeah.
So
and we're trying to work out how you could keep it clean, because that was something you'd said, that this is why Mike hates them, because they get messy very quickly. And so I know Juliet was saying maybe add some more things in, but I don't know whether you can have 3 or 4 that you could link rather than put them all in one, because you've just got so much there that you can't sort of see the wood for the trees. And I know you need to sometimes have all that complication in COVID stuff, for instance, because everything impacts on everything else, but I don't know how you'd actually see it.
Yeah, so I mean, Richard touched on that a little bit. So that there are things that you can do in InsightMaker that allow you to hide a lot of that complexity, so that it's sitting in the back end. So you've still got those variables. And Dave, when he presented his model, did exactly the same. That you're not seeing a lot of the variables that are in there. You can hide a lot of that away, so that when you're then getting other people to use this, then you can hide that complexity. So it's all happening, sort of underneath. But you can, it makes it easier for people to follow. And of course, by having the sliders and the narrative text and the storytelling elements, you can hide a lot of that complexity under the bonnet, so that people can see what's happening in the system without worrying about the 20 things that a particular variable links to, for example.
And Dan, this question came up: is it possible in a formulae, in a flow, for example, or a link in a variable, to reference another variable without actually having linked to it?
No, it shouldn't be.
Yeah, so this is where it gets messy. Is those dotted lines? They clutter things up, isn't it?
Yeah, I think you can hide them, I believe, because I've seen a lot of models where your variables are just sort of standalone, but they are actually linked into things. So I believe you can hide them, but I don't know offhand how you do that. But yes, you can.
The logical link has to be defined first for the
Yes.
variable to appear in the formula dialog as a reference to use.
That's right, yeah, because it
Because
won't.
we tried that and it said it can't find the variable, because I said, no, you don't need the link, you can just reference the variable.
Yeah.
Yeah.
It kind of almost be better if you didn't have to link them actually in that way, and you
It would be.
you got some, because that would be more, if you were doing this in Python, for example, that's what you do. You just say, well, I've got some variables over here and I can refer to them wherever I like. But InsightMaker does make you say, and this is linked to this, which it is good in some ways, because it's if you're from a usability perspective, you're building the model and make sure that you're thinking very carefully about what's linked into what. But you're right in that then gets very messy. Particularly if you've got a lot of variables, which you may well have. So, yeah, but there must be a way to hide them, because I've seen it done. So, and you can even then hide, obviously, the. Actually, I guess Dave Spencer knows, because
Yeah, the Devon CCG one. The Devon CCG one's variables were hidden on the right hand side, weren't they?
That's
with no
right. Yeah.
lines apparently coming out of them.
So ask Dave; he'll know. But yeah, so I know it can be done. But yeah, brilliant. Thank you. That was really good. I think that's really important, actually, and it's something that sometimes gets lost, and obviously particularly because obviously a lot of the modeling methods that we show you are sort of Python based, but because system dynamics is so visual in its nature, actually really thinking about, if you're going to share this and get people using it, that the usability, the visualization aspects of it are equally important, to make sure that people can understand what you're doing and actually be able to use it, which is an unused model is useless. So you want people to be able to use this stuff. So brilliant. Thank you very much.
Thank you.
And then the final group, got group 4, we've got Charlie, Eleanor and Jenna.
Yep, I'll just share my screen quickly. Can you see that?
Yep, see that?
So this model kind of leads on quite nicely from the previous discussion. So the person that made this obviously likes to compartmentalize everything and put it all in different boxes that are very neat and tidy. But the reason we picked this model is because it's quite an impressive model. So it's sort of lots of models built into one page, really. I'm not sure how they've done this, but it's quite good the way that they've used the tool to do that. So it's got good documentation as well. So they've got a little about section that you can expand, and it tells you what the model is trying to do, and how it works and that kind of thing. They've also got a backlog because it's still in development. So there's certain bits of it, like this seasonality part, that's still to be completed. And they've got a link to their Trello board where that's going on, and a change log as well to show what they've done. So quite good from that perspective. Another aspect of the model that we quite liked was that there were embedded data sets on NHS STPs and different levels of geography. So you can select the geography that you want to look at, and it adds in the age and sex split of the population.
Oh, that's neat.
For that particular area. So they've obviously embedded that in there. So the model consists of an SCIR model to model the spread of COVID, but then also the bit that we looked at was this health and care demand part of it, which then says, given that level of infection, what does that mean for hospital admissions, and critical care bed use, for example. So they've managed to hide the parameters in this little box here and give explanations of what each of them are. So you've got the TTI is the, time to isolation. So that'll be the time that you're still able to spread before you realize that you're infectious. And then once you've got the time to admission, and the rate of admission, I think, is this one here. So it's sort of, although it's nice to have it all compartmentalized, you sort of come up against the opposite problem, whereas you've got to dig around finding what everything means and stuff. So although it's nice to have it neatly hidden away, in some ways that makes it more difficult. And we sort of came to the conclusion with this one that yes, it's a very impressive and detailed model. However, we wondered whether this was really the tool for such a detailed model.
Yeah.
Whether maybe InsightMaker isn't ideally set up to, it's maybe better for simpler models. Something else we said. For the simulation of it, we looked at the different simulations, and so you're able to modify some parameters about at what point in time does lockdown start, how long does it last, and how effective is it. So we played around a bit with that. So one of the issues that we saw was that, so we set lockdown day to 90, and if you look at the admissions, those seem to drop quite immediately after lockdown, which we didn't think really reflected the delay between the lockdown and the sort of fall that you see in admissions. So that was one criticism that we had of it, and we wondered if they could build in more of a delay somehow to show how the decrease happens more gradually. Although you can set the lockdown reduction, so the percentage reduction in R during the lockdown period, so the effectiveness of reduction. So that impacts on the steepness of the curve, but it doesn't really give you a delay between lockdown and the reduction in admissions.
Right. Yeah.
So yeah, in all, we thought it was a really impressive and detailed model, but perhaps too much for InsightMaker.
Yeah, it's an interesting point, I think, and this is something you tend to find because particularly amongst academics who are so if you find certain academics see themselves as system dynamicists, they like system dynamics, that's their tool, so they'll always see that any problem as a system dynamics problem, and you might have other people who are discrete event modelers, and they'll always see something as a discrete event problem, and there are advantages to that in some ways, because in most cases you can think of different problems in many different ways, but sometimes you're right, it does mean that people don't always select the right tool for the job, and sometimes you end up I've done it myself, where I've tried to be building a system dynamics model and realized months later that it's not really a system dynamics kind of problem, and actually if I were just doing this in discrete event, I could do a very simple queuing model that would give me a much easier result and a much simpler model to understand, and that maybe I'm not using the best tool for the job. So it can be actually selecting the best way in which to represent your modeling problem is really important. And the other thing that jumps out at me from all of these things actually is that this really demonstrates the fact that there's a lot of reinventing the wheel. I mean, that there are, so InsightMaker is a platform in which it's very easy to share openly other models, and yet you've all demonstrated very similar models in many cases that have all been trying to tackle the same kind of thing. And again, it speaks to it is a real problem, even when you're developing kind of open source solutions, actually getting people to try and use these more generic models, because from the academic side, academics always think they're more intelligent than the other academics, so they'll do their own thing, they'll build their own model because it'll be better. And then from the NHS side, people are thinking, well, yes, but that was built up there and our problems are unique. And actually I think there's a lot of work to be done in terms of getting people to realize that you can, rather than trying to reinvent the wheel each time, to look at what's been done before, and where there are differences, build on that and make it specific. But actually there's a lot of really good models out there that could be used elsewhere and save a lot of development time, I think. So that certainly jumps out at me, and it is a known problem, certainly in modeling. Brilliant, thank you very much, and thank you to you all. Those are great little presentations, and hopefully that was a useful exercise in getting you to reflect on some of the models that are out there, and to think about how you might critically appraise models, which, as I say, is a really important skill. So if any of you are thinking of system dynamics approaches for your projects, then I'd encourage you to have a play around with InsightMaker a little bit more. As I say, it's a very, InsightMaker is, despite my love-hate relationship with system dynamics, it's certainly true that InsightMaker is a very nice piece of software to use, very intuitive, I think, and very easy to use that. So do have a play around and have a look back over the notes. So moving
Can I
into
just ask? Can I just
Yeah, sure.
ask about the project?
Mhm.
How much detail are you wanting us to go into on them?
So obviously you've only got 2 minutes, so that you're not going to be able to go into vast amounts of detail.
Yes.
The key things we need to know are what's the problem that you're trying to solve.
Yes.
Why is it important? That's a massive thing. Why should we care about solving this problem? What's the impact for patients and or the service? Why should we care about it? And then basically just talking about your what sort of methods you're looking to use. You're not going to be able to go into detail about how you're going to do it, but obviously
Yes.
we can connect the dots, and making sure that you sort of indicate what your organization's support for this. So is this something that's actually going to be implemented? So if you look in the Slack channel, which is application support, there's some information there about both the test and about the pitches, and it lists in the information about the pitches the 4 key things we're looking for, which is potential impact, practicability of the project within the time frame. Now obviously that's for us to judge, we'll be able to tell that, but just make sure that you're not proposing something so huge. I know it's a difficult one because 9 months sounds like a lot, but it's 1 day a week. So it's not by the time factor in sort of holidays and things like that, you haven't got a lot of time. So it's far better to do something that's focused and which is relatively simple. It doesn't have to be really really simple, but something that's manageable. Don't try and if you come with a project that says I'm going to model every aspect of the health and social care service in Devon and Cornwall, and that's going to raise alarm bells. So something that you think you could express it within a model quite simply, that you thought through the method that you're going to use. It seems to be a good fit for what you're trying to do. So if you're doing geographic modeling or discrete event for a queuing problem, and then, as I say, the evidence of support. So those are the 4 things that you need to make sure you touch on, because that's what you're going to be assessed on. We may well come back to you with more specific questions if you'd like more information, but in the pitch, those are the 4 key things, and by far the most important is the impact. Because that's how we're judged as an organisation. We need to be doing research that generates impact, and that extends to the HSMA programme in terms of the projects you do need to be impactful and important.
But it does depend on the impact, doesn't it? Because you could have get a research paper out of it, in which case then it would impact in a different way rather than actually impact the organisation you're working for.
Yes, so and that's a really good point. So when we talk about impact, we're very much not talking about conventional academic impact, because conventionally academic impact is measured in did you manage to get it in a good journal,
Yes.
and what was the impact factor of that journal, whereas the thing about us and the ARC generally is that that's secondary. Well, it's not even secondary, it's way down the list compared to the kind of big I impact, in terms of this is the change that we would bring about for patients and or the service and or victims if you're doing policing stuff. Why is this important for people? If you explain this to somebody on the street, would they care about it?
Yeah.
And why should they care about it? So that's very much what we'll be looking for in terms of impact.
Okay, that's great. And what is the date it needs to be ready for?
Sorry. So it needs to be submitted by this time. Well, it's by next Wednesday. So the 2nd, it needs to be in by midnight. So basically, by the time I I wake up on Thursday morning on the 3rd, they all need to be there. Yeah, by the end of Tuesday. Sorry, the end of Wednesday. Also remind us, this time next week on the 3rd, there is the Python test at 10 a.m. Make sure that you've read all the information on the Slack channel again about that. There is a optional Zoom call at 9:30 that you can join, where you can ask any last minute questions. Obviously, I can't tell you what's in the test, but I can give you general advice, and also if there's anything you want me to go over Python wise, that's your last chance to do it before you take the test, because obviously none of us will be able to help you in that hour.
But this is generic Python rather than using any of the particular.
Yes. So this is only basic Python stuff that you learnt in sessions 3A, 3B, and 3C. So the intro to Python stuff.
Okay.
So nothing in SymPy, nothing like that. There won't be anything on object-oriented programming or file reading and writing. File reading and writing mainly because that can be a nightmare because of your computer setup. So we don't cover that. But anything else in those sessions may be covered. So yeah,
Okay.
and certainly make sure you're all okay with functions. Functions are a big part of it.
Okay. So how would we? I just wondered are we going to send it to you, the results or something?
Yeah, so you'll be asked to, if you look in the information on Slack, it explains what you'll do. But basically at 10 a.m. next Thursday on Slack, the test will be posted as a PDF.
Yes.
It'll contain instructions and it'll tell you, basically you have to write a Python program in Spider and you save that as a .py file and then you send that as a direct message on Slack to me at the end of the test.
Okay.
But yeah, you basically write this single program. The other thing I would say about that is that the test is designed to give you marks rather than to deduct marks. So you don't have to. You may not finish it, and obviously that means you won't have a working program. You won't lose marks for that, other than what you didn't manage to do. You'll be given marks for everything. So if you had a .py file and you only had one line of code in it that didn't work on its own, but it was a correct line of code, you would get marks for that. So you get marks for everything that you do correctly.
That's good.
So yeah, the other thing, so make sure that you've sorted up on that, make sure you've read all the information and make sure you get your pictures in. And obviously next Tuesday and Wednesday, we've got 2 more training days. So if you're attending any of those sessions on Tuesday and Wednesday, make sure you followed the information the various trainers have put in the relevant module channels. So Tuesday morning, I'll be doing the next one on discrete event simulation, which I'll be getting you to build a discrete event simulation in SymPy. So you had a glance at that in the core session, and now I'll get you to do some hands-on stuff with that. So make sure you're prepped for the sessions that you'll be going to. And as I say, any questions, just post them on Slack. Great. Okay. Thanks, everyone, and have a good weekend. I'm off tomorrow, so have a good weekend, and see you next week for a very busy week for us all.
Thanks, Dan.
Cheers, everyone.
Bye.
Bye.
Thank you. Bye.